everyone, and welcome to a new video. Today we're going to be learning how to simplify expressions using like terms. So first of all, we need to know what like terms are. Like terms are terms that have the same variable with the same exponent. So let's write down an example. So 3a with an exponent of 4 and 6a with an exponent of 4 are both like terms. So 3a with an exponent of 4 and 6a with an exponent of 4 are both like terms. We know that because our variable is a and our exponent is 4. And here our variable is also a and our exponent is 4. Even though 3 and 6 are both different, they're still like terms because their variables are the same. And we need to know what coefficients are. So coefficients are just values that multiply with a variable. So these values can be different, but it doesn't really matter. So in our case, our coefficients are 3 and 6. So let's look at a question. 4x plus 3x. So first of all, in order to do this addition, we need to figure out if these two are like terms. And we know that they're like terms because they both have x as a variable. And because x and x is the same thing, we can add the coefficients. So we can write this as 4 plus 3 multiplied by x. So you don't have to write it like this. You can just write your answer straight away, but this is just for our personal understanding. So 4 plus 3 are coefficients, so they will add up to make 7, and then we can just multiply it with our variable. So it would be 7x is our final answer. Here's another question. So we have our like term, which is y. So if we add our coefficients for understanding, this is basically what it means. 6 plus 2 plus 1 multiplied by y. You don't have to write this down, but you can just do it straight away. So if we add our coefficients, we will have 6 plus 2, 8 plus 1, 9, and then our variable, y. If we look at another question, just like the one before, but with more terms this time, and here we have two different like terms, we can recognize that this term here and this term here both have the same variable b. And this term over here and this term over here, even though they don't have a variable, they're still like terms because they're both integers, so we can add them. So this question basically means we can add 8 and minus 5. 8 and minus 5 are both our coefficients for the same variable. So 8 and minus 5 are both being multiplied to b. And we can also add plus 9 and plus 12 because they are both integers, even though they don't have a variable. Again, you don't need to write the step down, it's just for personal understanding. So here, first of all, we would need to do 8 minus 5. So that would be 3, and it's being multiplied to our variable b. And then we can do this step over here, 9 plus 12, which is going to be 21. So 3b plus 21 would be our answer for this. Here's another question just like the one before, but here each term has a variable. So our like terms in this case are going to be 10a and 4a because they both have a variable of a, and each of these a's has an invisible exponent of 1 because their exponents are the same. Our second like terms are going to be minus a squared and 6a squared. Here we have an exponent of 2, and here we have an exponent of 1. So they're actually different. So when we add this, this would basically be 10 plus 4, and it's being multiplied by a with an exponent of 1. Here we just basically have a minus 1 multiplied by a squared, so we can do minus 1. And our other coefficient here is plus 6. So minus 1 plus 6 multiplied by our variable, which is a squared. So if, again, you don't need to do this step, but this is just for the understanding. So if we do this section first, this would basically be 10 plus 4, which is 14. 14a You don't need to write the exponent. Plus 5a squared. This is our answer for this question. So here we have another complex question just like the other ones. If we apply the same rules, we have to group our like terms first. So here we have a c cubed, and here we also have a c cubed, so they will go together. We also have a c squared, but we don't have another c squared here, so that's going to be by itself. We have a 2c and a negative c here. They can go together. And finally, we have a positive 5 and a negative 3. Because they don't have any variables with them, they go together. So now if we were to reorganize this and rewrite it, it would be c cubed plus this other c cubed here. Then we have our minus c squared over here. And we have our 2c and negative c. So plus 2c minus c. And then we have our plus 5 and minus 3. And that's how this question would look like. Now, if we were to add it, we know that we're going to do this section first. Then this stays by itself because there is no other term like that. Then we're going to do this section. And finally, we're going to do this section. So, c cubed plus c cubed is basically 1 plus 1. So it's going to be 2c cubed because there are two of them. Then we can write our minus c squared because there's nothing else with it. And then we're going to do our plus 2c minus c. That basically means 2 minus 1, which is 1. So we can just write plus c because there's only one of them. And then finally we have our plus 5 minus 3, which is 5 minus 3, which is basically 2. And if you've noticed, I wrote this in descending order, which basically means that the term that has the highest exponent goes first, and then this integer is last because it has no variable. So that's how you simplify expressions using like terms. Thanks for watching this video, everyone. Stay tuned for the next video because we will be doing equations. Thanks for watching and have a great day.